Hi everybody, so this lesson is just looking at what is the relationship between the phase difference between the current and the voltage for each of capacitors, inductors and resistors. So let's look at them one at a time. So when you have a capacitor, what I've drawn is the current goes up and down. Okay, however, if you think of it, once the capacitor is fully charged, the current stops, and when the capacitor is fully charged, the voltage across the capacitor is a maximum. So that just points out immediately that the voltage and current are not in phase. Okay, so the current through the circuit and the voltage across the capacitor are out of phase. So when the current is zero, that's when you have the maximum voltage across the capacitor. When the current is a maximum, the current flows fastest when the capacitor is not charged, or when the voltage across the capacitor is zero. So if I continue this, you end up with something like this. So the blue is the current, the circuit current, and the red is the voltage across the capacitor. So that tells you what happens when you have a capacitor in a circuit. Okay, so the current is out of step. Now if I continue this for an inductor, I might use another color, maybe I'll use green for inductor. So inductor, again, you've got your current, which is your sine curve. So this is my current. So the maximum induced voltage across the inductor is when the current is changing at a maximum rate. Okay, so the greater the change in flux, the greater the change in current, and bigger the induced voltage. So the change in current, the maximum rate of change in current, is actually given by the gradient of this graph. And if you look at the gradient, the change in current is when the current is zero. This is when it's sharpest, and at maximum current there is no change, right? Okay, so the greatest change in current happens when the current is zero. This is the greatest slope. So the voltage across the inductor is a maximum when the current is zero. When the current is maximum, it's not changing. So the voltage across the inductor is zero there, and then the same thing, carry on. Okay, and so on. So this red line, oh sorry, I forgot to change the color. So this red is the voltage across the inductor here. So it's kind of different for both these. Okay, and then if you look at the resistor, I might just draw that over here on the side. For the resistor, if you're looking at the voltage and current, what is the phase difference? So let's say this blue line is the current. Okay, so for the resistor, the voltage across the resistor kind of matches in step with the current. So when the current is zero, voltage is zero because of the V equals IR. So when V is zero, I is zero. Resistance is a constant. Okay, so they're in step. Oops. So what we have to remember is whatever combination we have of resistors, capacitors or inductors, the circuit current is always in phase with the resistor voltage. Okay, so that's what we have to keep in mind. And if you have just a capacitor, the circuit current actually leads the capacitor voltage by 90 degrees. If you have an inductor in a circuit, the circuit current actually lags the inductor voltage by 90 degrees, and that's what we have to keep in mind. And I hope that made sense. So bye for now.